Whenever you want to use it as an employee table, the Rajesh detail will not be available. When we are combining and when we are joining two operations, there will be some loss of data. Such type of decomposition is called lossy decomposition. In the relational one table, you may have more than one functional dependency that is represented using the axioms. Hello everybody, welcome to the one more session of database management system. Myself Indu J, Faculty of Computer Science Department, Vidhyaashram First Grade College, Temple of Excellence, MYSURU. Today we are going to discuss about the unit 3 in your syllabus, that is data normalization. Okay, let's see what is normalization and why we have to go for normalization. Different types of normalizations are there, and reason why we have to normalize the database, what is the advantage of using the normalization, that all we discuss in this particular unit. Okay, let's begin with anomalies in the relational database design. What do you mean by anomalies? Anomalies means some problem that exists when we are creating the database. That is called as anomaly. Okay, why we have to remove that anomaly? To remove the redundant data. In the database, if the database is very large and if you have a redundant data, for example, if you have a student 1 data more than 100 times, that will take 100 columns and the database size will be very large. And when you are searching the record of student 1, so all the 100 rows will be displayed. Whichever you want, you cannot specifically choose that. Okay, that is the problem when we have a redundancy. When we have a redundancy, these anomalies occur. In different types of anomalies are there. Let me consider insertion anomaly, deletion anomaly and updation anomaly. These are different types of anomalies we have. Let's see what is anomaly first. Anomaly means the inconsistency occurred in the relational table during the operation performed on the relational table. Inconsistency occur which is not consistent. One record is not as exactly as the another record. So that is called as inconsistency. There are three types of anomalies that can occur when database is normalized, not normalized. That is, when we are doing the operation, how many operations we have? Read, write and update. The basic operations what we have. So these are depends on that we have three types of anomalies. This is one is insertion anomaly, updation anomaly and then deletion anomaly. Three types of anomalies we have. Let's see what is anomalies. Okay, here we have a table, worker table. In this worker table, what exactly we are inserting? We are inserting the values of Ramesh, Amit, Vikas and Rajesh. How many employers or how many workers are there? Basically have 1, 2 and 3 and 4. Only 4 workers are there. But how many rows we are having? We are having 4 plus 2, 6 rows. Why? Because this is repeated. Right, Ramesh record is repeated and Vikas record is also repeated. So this is called as anomaly, having more than one copy of each. So here you can see the key attribute, what is that? Worker ID is also same. That gives you a problem when you are fetching the data. So this is all about anomaly. Let's move on to the updation anomaly. What do you mean by update anomaly? When we update some rows in the table and if it leads to the inconsistency, when we are updating, it should be updated in all the columns with all the row wherever that particular data is present. So that is what updation leads to an inconsistency of the table. When this anomaly occurs, this type of anomaly is known as updation anomaly. For you can take an example of the previous table. This is a previous table where in the above table, if you want to update the address of Ramesh, okay, then we have to update all the rows where the Ramesh is present. In how many rows Ramesh is present? In 2 rows Ramesh is present. In one row you have updated the address of Ramesh. In another row you forget to update the address of Ramesh. Then it causes a updation anomaly. Next what we have is insertion anomaly. If there is a new row inserted in the table and it creates an inconsistency in the table, then it is called as a insertion anomaly. Insertion creating the inconsistency. Here you can say with the table, if I want to add one more worker, say with a worker ID 80 and the name is Ram, okay, with department and MYSURU. Okay, what if happens here? I have updated one column, that is worker ID. I have inserted one column, worker ID, worker name, but here I have not given any value. Then worker address is inserted newly. But if we are not inserting the worker belongs to which department, right? So this type of insertion leads us to the insertion anomaly. That is what we have. We create a new table, new row of the worker, and if it is not allotted with any department, then we cannot insert it in the table. So it will create an insertion anomaly. When we are inserting, you have to fill all the attributes of that particular record. If any one attribute we are not filling, that causes the insertion anomaly. Next what we have is deletion anomaly. If we delete some rows from the table and if any other information or the data which is required is also get deleted from the database, this is called as deletion anomaly. For example, in the table what we have only one worker Rajesh with a single record. If this Rajesh has to be fetched, if that particular information of Rajesh has to be fetched, we have to use this. If I delete this particular row, what happens? All the data which is related to the Rajesh will get deleted. Whenever you want to use it as an employee table, the Rajesh detail will not be available. That is called as deletion anomaly. That causes the inconsistency. When employee table you have a Rajesh, but in the worker table you don't have a Rajesh detail. So that causes deletion anomaly. When you are deleting, it provides an inconsistent data that causes deletion anomaly. Next what we have is decomposition. How to overcome from these anomalies? The solution, simple and the best solution what we have is a decomposition. Decomposition means what? Dividing the things. Okay, that is what the thing. The process of decomposition in the Dbms help us to remove the redundancy, inconsistency and anomalies from the database when we divide the table into number of table. What we are doing? We are doing dividing. We are dividing the complete a large table into small number of tables. The process of decomposition refers to dividing the relation x into either x1, x2, so on up to xn. How many tables we can do? That depends on n number, and decomposition is a dependency preserving as well as lossless. We'll see what is dependency preserving in next slide. Okay, decomposition in Dbms removes the redundancy, anomalies and inconsistency from the database by dividing that into multiple number of table. So now what we have is type of decomposition, lossless and lossy. As name itself indicates, lossless means when we are dividing the table, a large table into sub-tables, if you are losing some of the data of the table is called as lossy decomposition. If you are not losing any data, that is called as lossless decomposition. Let's see what is lossless decomposition. So, if the information is not lost from the relation that is decomposed, then the decomposition will be lossless. When we are dividing the table into 2 or 3 sub-tables, the data which is present in the base table should not be deleted, should not have any effect on that. So that is lossless. The lossless decomposition guarantees that the join operation will result in the same relationship. So consider if I have a relationship R with attribute A, B, C and D, right? I am dividing this particular relation R as R1 and R2. What all attributes I have here? In the R1, R2 I have A, B. Here R2 I have A, C and D. So now this table 1 is related to the relation 2. How it is related? Using a one attribute, that is A attribute. When we do join operation over this, join R1 and R2, it will produce as what? R without any modification, that is A, B, C and D without any modification. When we do the join operation, it will result the same relation as it is decomposed. That is called as lossless decomposition. So here we have an example. So consider the example employee department table. In the above relation decomposed into two relations. One is employee and one is department. How many attributes we have? 1, 2, 3, 4, 5 and 6 attributes we are having. We are dividing these 6 attributes into two different tables. In the first table, what will be having? Employee ID, employee name, employee age and employee city. That belongs to which table? Employee table. And this department ID and department name with employee ID will become one more table. Let's see the decomposition of the particular table. That is employee ID, employee name, employee age and employee city as employee table, and employee ID, department ID and department name as department table. Here employee ID of the both the table should be same because it provides the relationship between two decomposed tables. So this is a lossless decomposition. Okay, this is a lossless decomposition because when we are joining it together using the employee ID, all 6 attributes of the table will be displayed. Next, what is lossy decomposition? Here, the name suggests when the relation of decomposed into two or more relational schema, the loss of information is unavoidable. The loss of information is what? Unavoidable when the original relation is retrieved. When we are combining and when we are joining two operations, there will be some loss of data. Such type of decomposition is called lossy decomposition. So same example with all the 6 attributes. Let's see how we are going to decompose this. Okay, after decomposition, here I have employee ID, employee name, employee age and location as a 4 attributes. Here I have a 2 attributes. There are 2 different tables, right? 2 different tables we have. There is no common attribute that provide relation between 2 tables. That provides relation between 2 tables because nowhere we cannot relate these 2 tables. Okay, that is we are saying that this is a loss of data. This data is completely lost. So it is called as lossy decomposition. Okay. Next, dependency preserving. What you meant by dependency preserving? As it is related database we are dealing with, every attributes or every tuple will be related to the other. Hence, it is dependent on other. We have to preserve such dependencies. So that is what it says. It is an important constraint of the database. That is an important rule when we are designing the database. In the dependency preservation, at least one decomposed table must satisfy every dependency. That is what the example we have given. R1 and R2. R having how many attributes? A, B and C. R1 having A, B and R2 having A, C. in the dependency preservation, at least one decomposed table must satisfy every dependency. Which is a dependent attribute here? This is a dependent attribute. Either one table should have the dependent attribute. If a relation R is decomposed into the relation R1 and R2, then the dependency of R either must be the part of R1 or it must be the part of R2 derivable from the combination. That is what we have explained in this diagram. For example, suppose there is a relationship ABR with the attribute ABCD with the functional dependency. So, functional dependency is represented as A determines BC. With the functional dependency set, A determines BC, that is attribute A, it is preserving the dependency with the B and C attributes. Then the relational R is decomposed into R1 and R2. Either this dependency, functional dependency, should be the part of R1 or it should be the part of R2. Then we can say that dependency has been preserved. Okay, next what we have is functional dependency. The functional dependency, that is FD, is the constraint that determines the relation of one attribute to the another attribute in the database management system. What it is? It determines the relation from one attribute to the another attribute. If I say employee ID is one attribute and employee name is another attribute, it provides the functional dependency, provides the relation between employee ID and employee name. Functional dependency helps to maintain the quality of data in the database. Why we have to go for functional dependency? To maintain the quality of data in the database management system. It plays a vital role to find the difference between the good and bad database creation or design. Functional dependency is denoted with the arrow mark, and the functional dependency of X on Y is represented by X arrow Y. How do we represent the functional dependency? For EID determines E name. This is how we represent the functional dependency using the arrow mark. Next what we have is example for the functional dependency: employee number, employee name, salary, and then the city. In this example, we know that the value of the employee number, we can obtain employee name, city, and the salary. What it is saying? Functional dependencies of the table employee is, that is, employee number determines employee name and employee number. From employee number we can get the employee salary, right? And from the same employee number we can get the city. That is how we represent the functional dependency. Axioms is a set of interference rules used to interface all the functional dependency in the relational table. In the relational one table, you may have more than one functional dependency that is represented using the axioms. In axiom, we have a minimal cover functional dependency and maximal cover functional dependency. What do you mean by minimal cover functional dependency? E is a minimal set of dependency F that is equivalent to E. Every dependency in the table F has a single attribute from the right hand side. So, this is A produces B, C. This is our LHS. So, this is our RHS. Right. What minimal cover says that here at the RHS we should have a single value, that is a single attribute for its right hand side, and we cannot replace any dependency of X determines A in F with the dependency of Y determines A, where Y is a proper subset of X. So this is one condition. At the right hand side, it should have only one attribute, and at the left hand side, it's saying that X determines A and Y determines A. We cannot do this because X is a proper subset of Y. What you mean by proper subset? Exactly the same. X is equals to Y. That is called as proper subset. Subset means sum of values of Y is present in X. That is a subset. Proper subset, all the values of Y present in X. X is equal to Y. So it should not be the same, and still have to set the dependency that is equivalent to F. There are two conditions. If we want to say the functional dependency has a minimal cover, first is what? The right hand should have only a single attribute, and the second, it should not have a proper subset. Left hand side should not have a proper subset of another functional dependency. When coming to the maximal cover, the maximum possible number of the functional dependency is a number of possible left hand side multiplied by number of possible right hand side. That is RHS into LHS. Left hand side, how many possible attributes or functional dependencies are there in the left hand side multiplied by how many functional dependencies are there in the right hand side. Combining together, you will get the maximal cover of the functional dependency. Next we'll move to the types of functional dependency. The functional dependency in the database, there are mainly 4 types of functional dependency. One is multivalued, trivial, non-trivial and transitive dependency. What is multivalue dependency? A determine A, B, C, D. So this is called as multi-valued dependency, functional dependency. When it comes with the trivial determines, A determines itself. That is called as trivial functional dependency. Some attribute determining itself. It is common that it is must that each attribute determines itself. That is called as trivial. Non-trivial, A determines B. Okay, except trivial, if it is determining some other attributes, that is called as non-trivial. Transitive dependency, here in the transitive dependency, A determines B, comma, B determines C. In turn, what we are doing? A determines C. That is exactly as that of your transitive law in the mathematics. That is, indirectly we are C is determined by A. That is called as transitive dependency. Understood? How many types of functional dependencies are there? 4 types of functional dependency. One is multi-valued dependency, RHS. Here we have more than one value. That is called as multi-valued dependency, or it can be LHS, AB determines C. This is also a type of multi-value functional dependency. Then trivial functional dependency, the attribute defining itself is called as trivial functional dependency. Non-trivial, apart from itself, the attribute defining another attribute, that is called as non-trivial functional dependency. Transitive, nothing but A determines B, B determines C. In turn, A determines C. That is transitive functional dependencies. What is the advantage of having the functional dependencies? Functional dependency can avoid data redundancy. So far what we are discussing is to remove the redundant data. So functional dependencies helps to remove the redundant data. Therefore same data do not repeat at the multiple location of the database. It helps to maintain the quality of data in the database. It helps to remove the redundancy, helps to have the quality of data, and it helps to define the meaning and the constraint of the database. Meaning and then the constraint of the database. It helps you to identify the good database and bad database design. It helps you to find the facts regarding the database design. Functional dependency mainly help you to design how the database design should be. You will get to know depending on the functional dependencies. Thank you.